Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Sciences, SOS, others programs. Appreciation course on environment, ACE. Block-2 Environment Management. Unit-6 Conservation and Management of Environment. 6.1 Introduction. In the previous units you have studied how the consumption-oriented technological advancement and economic development is posing serious threats to the environment today. Ecosystems critical to the functioning of the Earth's life-supporting systems continue to be undermined, and land degradation threatens food security and livelihoods. As a result, conservation and management of environment has become absolutely necessary. How much better off all of Earth's people would be when we collectively pursue sustainable development as our common agenda? This can and will happen only with the active support of citizens everywhere. Interventions for sustainable development are being made by environmental activists, governments and international institutions with the active assistance of non-governmental organizations and other community-based groups. But the ultimate goal of a sustainable, environment-friendly way of life is still a far cry. During the last decade, the above-mentioned new partnerships have led to a common understanding of most fundamental priorities facing all nations: reducing the risks of climate change, conserving and sustainably using the stock of biological diversity, protecting international waters, phasing out ozone depleting substances, combating land degradation, are the issues encompassing the life of all peoples, political systems, sectors, species and generations. These are the problems which must be solved together and soon. These are also required to alleviate poverty and improve quality of life for all. In this unit you will be introduced to the various activities identified by the world community causing environmental degradation. You will also be informed about the requisite policy guidelines, action plans, and management techniques being adopted by the countries to achieve the goal of sustainable development, along with conservation and preservation of the environment. Objectives. After studying this unit, you should be able to times describe the geographic information system and its environmental applications. Times discuss the challenges faced in conserving and managing the environment. And times explain the basis of various measures evolved to meet the challenges of conserving and managing the environment. 6.2 Assessing the status of the environment. The first and foremost step in the conservation and management of environment is to acquire information related to its status and the various forms and causes of degradation of the environment in different areas. The availability of data related to various aspects of environmental degradation should enable governments to frame policy guidelines, chalk out action plans, and introduce techniques to achieve the goal of sustainable development that also regenerates the environment. We shall now briefly describe a system that has the capability of collecting, storing, retrieving, analyzing, visualizing, and interpreting the information related to all aspects of the environment. It is known as the Geographic Information System, GIS. Geographic Information System. A Geographic Information System, GIS, is a collection of geographical reference data, personal and computational tools designed to efficiently provide information for large tracts of land. GIS technology integrates common database operations, such as query and statistical analysis, with the unique visualization and geographic analysis benefits offered by the maps. These abilities distinguish GIS from other information systems and make it valuable to a wide range of public and private enterprises for explaining events, predicting outcomes, planning strategies, and in decision making. GIS technology can be used for scientific investigations, resource management, and development planning. For example, GIS allows emergency planners to easily calculate emergency response times in the event of natural disaster, or it can be used to find wetland that needs protection from pollutants. GIS technology integrates powerful database capabilities with the unique visual perspective of a good old-fashioned map. GIS technology can be applied to many lines of work, such as agriculture, business marketing, disaster management, environmental management, forestry, geology, hydrology, land use planning, mapping, risk management, site planning, etc. It can be used to study drainage systems, assess groundwater, visualize watersheds, and many hydrological applications. GIS has been proven suitable for disaster mapping, remote sensing, and disaster mapping techniques have greatly helped the relief management efforts. Early warnings of drought conditions, floods, cyclones, volcanic eruptions, fires, earthquakes, and landslides help to undertake contingency strategies and to organize relief where and when it is most needed. Environmental professionals use GIS to produce maps, inventory species, to measure environmental impacts, and trace pollutants. The environmental applications of GIS are almost endless. For example, satellite remote sensing and GIS have demonstrated that together they have the potential to provide comprehensive information on various facets of forest management. It can be used in times forest cover assessment, times forest stock mapping, times vegetation type mapping and monitoring changes, times deforestation and encroachment monitoring, times biodiversity conservation planning, times habitat management, and times protection of wildlife and wildlife habitat. GIS is used in predicting forest fires, detecting forest fires, and estimating forest loss. Biomass and productivity estimates have also been made using GIS. It is helping in wetland conservation and controlling land degradation. GIS and related technology will help greatly in the management and analysis of large volumes of data, allowing for better understanding of terrestrial processes and better management of human activities to maintain world economic vitality and environmental quality. However, GIS and remote sensing techniques have to be effectively used to complement and supplement ground data collection. These systems only provide synoptic large area coverage that has to be integrated with detailed time series information coming from ground sensors to provide appropriate database for any application. Sustained efforts are required for integrating GIS with local ground-based data if we wish to face the challenges in environmental management. 6.3 Challenges in conserving and managing the environment. The United Nations has identified 5 challenges in the next century for the world community for sustainable development and conservation of the environment. These are biodiversity loss, climate change, water pollution, ozone layer depletion, and land degradation. Biodiversity loss. You will agree that all human beings have a right to clean air and water, non-toxic food, and a healthy environment. All these are under tremendous threat. In the most advanced nations of the world, these concerns are prompting all nations to get together and devise common strategies for sustainable Development that is environment-friendly and regenerates resources. Biodiversity is a source of significant economic, aesthetic, health, and cultural benefits, which form the foundation for sustainable development. Although estimates vary, there is a general scientific consensus that the world is becoming less biologically diverse in terms of genes, species, and ecosystems. However, the role of biological diversity in the sustainable functioning of the biosphere is not well understood. There is little understanding of the social, economic, or ecosystemic consequences of a less biologically diverse world, and scientific knowledge is limited. Scientists estimate that less than 15% of all species have been described so far. Tables 6.1 and 6.2 enlist the number of species of plants and animals threatened due to degradation of their ecosystems. Table 6.1 Comparative statement of recorded number of animal species in India and the world. Look at the screen. Table 6.2 Summary of plant conservation status information at WCMC. Look at the screen. Rapid loss of biodiversity poses a global threat to human well-being. The scale of human impact on biological diversity is increasing exponentially, primarily because of worldwide patterns of consumption, production, and trade. Agricultural, industrial, and settlements development, and population growth. Figure 6.1 demonstrates the growth in India's population in the past few decades, as well as future projections. Biodiversity is not equally distributed throughout the world. Rates of biodiversity loss vary across ecosystems, and ecosystems vary in their level of species richness. For example, tropical ecosystems are estimated to house between 50 and 90% of total species. Figure 6.1 India's population. Look at the screen. Times vegetation type mapping and monitoring changes. Times deforestation and encroachment monitoring. Times biodiversity conservation planning. Times habitat management, and times protection of wildlife and wildlife habitat. The pattern of consumption and production in the world has been illustrated in Table 6.3. Table 6.3 The pattern of consumption and production in the world, 1995. Look at the screen. Neither the economic nor the ecosystemic value of biodiversity resources is well understood. In particular, there is insufficient knowledge of the interdependence of species within ecosystems and the impact of the extinction of one species on others. Reducing the rate of biodiversity loss and conserving existing biodiversity as a basis of sustainable development remain major global challenges. Climate change. Human activities have been substantially increasing the atmospheric concentrations of greenhouse gases. These increases enhance the natural greenhouse effect and will result, on average, in additional warming of the Earth's surface and lower atmosphere, which may adversely affect natural ecosystems and humankind. Melting ice caps and the thermal expansion of the oceans are of immediate concern to residents of low-lying island states and coastal areas. In time, greenhouse gas-induced climate change threatens to play havoc with almost everyone's weather, disrupt agricultural trade, deal a strong blow to already weakened ecosystems, forests, wetlands, and coral reefs, and give new impetus to the spread of infectious diseases. The United Nations Framework Convention on Climate Change, FCCC, which became effective in March 1994, was an international acknowledgement that changes in the Earth's climate and its adverse effects are a common concern of humankind and call for the widest possible cooperation by all countries. While recognizing that various actions to address climate change can be justified economically in their own right and help in solving other environmental problems, the Convention agreed on the need for all countries, especially developing countries, to have access to resources to achieve sustainable social and economic development. As developing countries progress towards sustainable development and their energy consumption grows, they will have to consider ways of achieving greater energy efficiency and controlling greenhouse gas emissions, including how to apply new technologies in ways that are economically and socially beneficial. India's total electricity demand and supply over a period of 15 years is shown in Table 6.5. Fig 6.3 illustrates India's energy consumption by fuel in the year 1995, and Fig 6.3b depicts per capita energy consumption in India, past as well as future projections. Look at the screen. Table 6.5, Demand and Supply of Electricity in India. Figures in billion kWh. Fig 6.3, A. India's energy consumption by fuel in 1995, B. Per capita energy consumption in India. Table 6.7, World total energy consumption by region, reference case. 1990 to 2020, quadrillion BTU. International waters. The world's water resources are under enormous stress, and the ecosystems, people, and economic development that depend on these resources are facing a precarious future. Global environmental concerns relating to international waters include times degradation of the quality of transboundary water resources caused mainly by pollution from land-based activities, toxic chemicals, nutrients, pathogens, oxygen-demanding wastes, sediment, and debris. Times physical habitat degradation of coastal and nearshore marine areas, lakes, and watercourses, for example, wetlands, mangroves, estuaries, coral reefs, as a result of inappropriate management, for example, land conversion, dredging, coastal construction, and irrigation. Times introduction of exotic species that disrupt aquatic ecosystems and cause toxic and human health effects, untreated ballast water discharges from ships, for example. Times excessive exploitation of living and non-living resources due to inadequate management and control measures, for example, overfishing and excessive water withdrawal. Degradation of freshwater and marine systems, and of surface waters as well as groundwater resources, is causing irreversible environmental effects, hardship for the poor, real losses to the economy, human health concerns, and the need for costly investments to mitigate the damage. Marine and freshwater systems constitute important sources of income and food for a large part of the world's population whose food and water supplies are now at risk. For example, globalization of technological advances in the fishing industry, pollution, and habitat destruction have depleted fish stocks to dangerously low levels and placed food security in jeopardy in many areas. International issues of global significance have yet to be effectively addressed. Availability of surface and groundwater in India and its requirement for different uses is illustrated in Table 6.8 and 6.9, respectively. Table 6.8, Mean flow utilizable surface and groundwater resource in India basin-wise, in billion cubic meters. Look at the screen. Table 6.9, Projected water requirement for different uses, in BCM. Table 6.10, Status of hazardous waste generation in India. Figures in million tons. A consensus has emerged that a more comprehensive approach to water Resources management is needed, one that is cross-sectoral, integrates ecological and development needs, and is based on holistic analysis of the carrying capacity of the water environment. In this approach, the river basin, groundwater system, coastal area, or large marine ecosystem typically serves as a management unit on which to base changes in the way that sectoral development activities are conducted and how priority environmental interventions are made. In many instances, action programs are needed to restore proper functioning of ecosystems or remedy major human health risks. Such a comprehensive approach that integrates actions across sectors is new to most countries, difficult to implement, and even harder to achieve when actions must be coordinated among countries. Table 6.11 lists some polluted river stretches of India. Possible source of their pollution is also depicted. Table 6.11 List of polluted river stretches, India. Look at the screen. Ozone layer depletion. The stratospheric ozone layer is a protective shield that absorbs most of the ultraviolet radiation that could harm living organisms on Earth. Stratospheric ozone is constantly being created and destroyed by natural photochemical processes that are in dynamic equilibrium. This equilibrium has been disrupted by the release of anthropogenic chemicals, especially chlorine and bromine compounds such as chlorofluorocarbons, CFCs, halones, and a broad range of industrial chemicals used as refrigerants, foaming agents, aerosol propellants, fire retardants, solvents, and fumigants. As a result of these chemical processes, the ozone layer is being depleted. Scientific observations show significant depletion throughout the year in both the northern and the southern hemispheres at middle and high latitudes, although not yet at the tropics. This depletion allows more ultraviolet B radiation to reach the ground, which could raise the incidence of skin cancer, cataracts, other irreversible eye damage, and could also suppress the immune system. In addition, even minor increases of ultraviolet B radiation could disrupt ecological food chains, affecting agriculture, fisheries, and biological diversity. Governments responded to concerns about ozone depletion by adopting the Vienna Convention on the Protection of the Ozone Layer, Vienna Convention, in 1985, the Montreal Protocol on Substances that Deplete the Ozone Layer, Montreal Protocol, in 1987, and amendments to the protocol in London in 1990 and Copenhagen in 1992. By June 1995, almost 150 countries had ratified the Montreal Protocol. These agreements have significantly slowed the atmospheric accumulation of several major ozone-depleting substances. For example, worldwide production and consumption of CFCs decreased by more than 50% between 1986 and 1994. Many of the remaining major producers and consumers of CFCs and other ozone-depleting substances are required to ratify the Montreal Protocol control measures to phase out major ozone-depleting substances. There is a risk that, unless insisted, these countries will continue to produce and use such substances and therefore negate much of the ozone layer protection that has already been achieved. Ozone depletion is also linked to other global environmental problems. For example, both ozone and ozone-depleting substances are greenhouse gases. While the major ozone-depleting substances have very strong global warming potentials, the ozone depletion they have caused has had a net cooling effect. that has offset about 20% of the radiative forcing due to the atmospheric accumulation of greenhouse gases between 1980 and 1990. In restoring the ozone layer, it will be necessary to minimize the global warming that might be caused by substitutes for such substances. The relationship with biodiversity is more direct. Protection of the ozone layer is a prerequisite for conservation and sustainable use of biodiversity. Ozone layer depletion, leading to increased ultraviolet radiation at the Earth's surface, would endanger species already under threat and biological diversity in general. Land degradation. Prevention and control of land degradation, especially desertification and deforestation, are critical to achieving sustainable development at the national level. They are also central to global environmental progress. The environmental and economic consequences of land degradation are not confined to the countries where it occurs. Its effects: loss of biodiversity, reduced atmospheric and subterranean carbon sequestration, and pollution of international waters can be significant and global. Land degradation is linked to biodiversity at the ecosystem level, where it decreases the productivity of the habitat, decreases resilience and integrity of the watershed and aquifer, increases soil erosion and sedimentation of aquatic ecosystems, increases the severity of floods and droughts, and enhances desertification. In some cases, the relationships that link land degradation and biodiversity loss may be simple and straightforward, such as habitat loss leading to species extinction, while in other cases they may be complex and less obvious. For example, land degradation can lead to occurrence of alien invasive species that are able to compete better than endemic species and therefore lead to local extinctions of endemic species. In addition, it is sometimes difficult to separate land degradation due to short-term human actions from long-term ecological or climatic processes. For example, we know that perturbations such as fire and grazing have been part of many native savanna ecosystems for thousands of years, and species diversity and composition have adapted to them. If management decisions disregard these long-term processes, then decline in biodiversity and local extinctions may result. Widespread deforestation and desertification reduces local, regional, and global carbon sequestration and potentials for carbon sinks. Deforestation of organic soils leads directly to increased carbon emissions. Global climate change, particularly enhanced greenhouse effect, will result in changes in land use systems as well as directly affect vegetation. For example, there will be species migration to higher latitudes and altitudes as a result of warming. This is already visible, for example, in some tropical mountains. Sea level rise will adversely affect aquatic ecosystems, and saline incursion can cause salinization of surface soils. Land degradation has many implications for international waters portfolio. Upstream soil erosion leads to sedimentation and siltation downstream, including coastal zones, which can affect water flow as well as biodiversity and agricultural potential. Pollution from organic, e.g., agricultural, and inorganic wastes, e.g., industries, can be transported across national boundaries, affect fisheries and other freshwater biodiversity, and accumulate in estuaries. Large water-demanding schemes upstream, e.g., irrigation, dams, affect water flow downstream and lead to desiccation and land degradation. Land degradation upstream affects water flow downstream, often leading to flooding and changes in watershed characteristics, e.g., river trajectories, downstream, and impact coastal zones. Land degradation due to inappropriate land uses and excessive exploitation of the vegetation result in siltation of shared basins, pollution, build-up, lowering of water levels, and major impacts on fisheries, tourism, and other uses of the shared basins. Many aspects of these challenging problems can be taken care of by individual initiative and collective action. For this, we need to know about various measures being adopted worldwide. 6.4 Measures to meet the challenges. Countries all over the world have endeavored to address land degradation as it relates to biodiversity, climate change, and international waters and are taking a variety of actions to stop it. These include improved farming and grazing practices, afforestation, reforestation, and forest management, upgraded water management, and institutional and policy reform for better land use policies. Throughout history, nations have identified security threats as military and political challenges coming from a sovereign power. More recently, we have come to see the civil unrest that is the most common form of political violence in our world today as a source of wider instability. But we need to move beyond these familiar definitions to a new understanding of the global environmental situation as a very real threat to the security of nations and of the international order. Once that shift in outlook takes hold, the resources for mounting an effective defense will follow. Once environmental concerns become a mainstream element in the strategic planning, economic calculations, and political dialogue of nations and their leaders, genuine progress towards sustainable development will also follow. Any strategy that aims to sustainably manage the Earth's environment must build on the positive ties between development and the environment, while breaking the negative bonds between economic growth and environmental degradation. Business as usual can give way to alternative scenarios with positive outcomes for all. But first, we must incorporate environmental values into all our priorities and actions. These include repositioning of our economies, not necessarily toward producing less, but definitely toward producing and consuming differently. Efficiency, innovations, substitution, and structural change can have powerful effect on the relationship between economic activity and the environment. Industries are not cutting back their wastes and emissions due to non-availability of right incentives, regulations, charges, and inducements. The fragile and limited resources, poorly defined or non-existent property rights, limited access to credits and insurance markets, and low income are generally restricting the people to invest in long-term environmental protection and resource conservation. The governments need to implement market-based policies in order to accelerate transition to sustainable development. The key measures to be taken are times introduction of new incentive systems, times elimination or reduction of price subsidies, times clarification of property rights, and times open trade and investment policies which promote environmental friendly technology transfer and more efficient allocation of resources. Approach to the above suggested measures for sustainable development of the environment may be through finance, political, or both. Benefits of these can be great and certain. The cost of inaction to human health and welfare and to our natural environment will prove much greater over the long years. We shall now learn about measures to be taken for sustainable use and development of the environment. Sustainable use of biodiversity. The success of biodiversity conservation efforts will depend on how well the overall landscape is managed. It is simply not possible to conserve all species in a region by using conservation areas alone. Biodiversity conservation and sustainable use must also be achieved outside the designated conservation areas, including protected areas. It must be at the natural and modified surrounding areas also. Restoration and rehabilitation of unique habitats under threat in areas of high diversity or endemism will also contribute to conservation and sustainable use. Activities that involve biodiversity management within the productive sectors of an economy are likely to lead to long-term sustainability because they will help address the underlying causes of biodiversity loss. Several sectors, such as forestry, agriculture, fisheries, and tourism, draw upon biodiversity assets. Incremental costs of activities for conservation and sustainable use of biological resources are required to be developed within national policy and regulatory frameworks and within the context of the operational programs of the country. They may include times integration of biodiversity conservation and sustainable use objectives into land use and resource use management plans, times establishment of regulatory frameworks and incentive systems to minimize the harmful impact of economic activities on natural resource use, times facilitation of access to and transfer of and cooperation for joint development of technology for sustainable management and use of biodiversity resources, times promotion of sustainable production and use of natural products such as non-timber forest products, wild relatives of domesticated species, and agrobiodiversity-related products, including the development and implementation of sustainable harvesting and marketing regimes, times development of environmentally sustainable nature-based tourism, times participatory schemes for sustainable natural resource management, including that of buffer zones by local communities, indigenous groups, and other sectors of society, and times initiation of integrated pilot projects to provide alternative livelihoods to communities consistent with biodiversity conservation and sustainable use. Sustainable use of biological resources is a prerequisite for their long-term conservation. However, in most cases, it is not possible to accurately predict the impacts on ecosystems, habitats, species, or gene pools of innovative approaches to conservation and sustainable use of biodiversity. In addition, the risks of introducing perverse incentives that lead to over-harvesting and destruction of natural resources are significant. Activities that involve harvesting of wild resources, for example, wildlife, non-timber forest products, pose special risks. It is, therefore, a priority to develop sustainable use methods that do not degrade biodiversity in agriculture, forestry, and fisheries. Therefore, sustainable use activities will require close monitoring of species selection, information on current occurrence, density, and other demographic parameters of biological resources, including yield studies and regeneration surveys, and actual impacts of harvesting, so that harvesting levels and methods can be adjusted as needed. Biodiversity loss occurs through direct and indirect causes. These causes are typically multiple and synergistic. They involve complex interactions of demographic, social, ecological, economic, and cultural factors. The levels of causality may include proximate causes, where human action, such as land clearing, directly induces biodiversity loss, intermediate causes, such as inappropriate economic policies and legal ownership and tenure. Circumstances and ultimate causes, such as population growth, poverty, low standards of living, lack of social development, which increases pressure on natural resources, and overconsumption of resources. Countries addressing the underlying causes of biodiversity loss must ascertain the range and importance of causal factors and their role in biodiversity loss and its amelioration. For example, appropriate adjustments in economic and social development policies may offer cost-effective, long-term solutions to biodiversity protection problems. Concentrated efforts on addressing the proximate and intermediate causes of biodiversity loss through the implementing agencies' regular assistance and awareness-building programs of the country facilitate efforts to address the ultimate causes of biodiversity loss. The operational programs may include times identification and analysis of major causes, proximate, intermediate, and ultimate of biodiversity loss, activities to build awareness of these causes, and assessment of feasible actions to address them. Times application of analytical tools for decision making, for example, valuation, indicators, impact assessment, promotion of partnerships to address the underlying causes, dissemination and systematic sharing of information, including on best practices and incorporation of biodiversity concerns in the mainstream activities of implementing agencies. Times incremental investments and technical assistance to help implement remedial measures such as capacity building, including human resource development, shifts in economic and social policy, and introduction and strengthening of legal, institutional, and regulatory systems, and to promote the integration of biodiversity conservation in agriculture, forestry, fisheries, wildlife and water management, tourism, and other relevant sectors. Times introduction of innovative measures, including economic incentives, for the conservation and sustainable use of biodiversity. Stabilization of climate. Objectives of the countries may be the stabilization of greenhouse gas concentrations in the atmosphere at a level that will prevent dangerous anthropogenic interference with the climate system. Such a level should be achieved within a time sufficient to allow ecosystems to adapt naturally to climate change, to ensure that food production is not threatened, and to enable economic development to proceed in a sustainable manner. Global environmental benefits will be obtained to the extent that the above mentioned objective of all countries is met. Degrading dryland soils and burning biomass are globally significant sources of greenhouse gas emissions. Prolonged or frequent drought and soil degradation undermine the soil's capacity to store carbon. Frequent and large-scale biomass burning reduces the carbon stored in vegetation and trees, increasing carbon emissions, and can contribute to land degradation. Activities relating to stabilization of climate change may therefore take land degradation issues into account. The following are illustrative of activities that accomplish above-mentioned objective. Times introduction of rural renewable energy projects, such as solar, wind, and biomass energy for lighting, water heating, cooking, and water pumping. And energy efficiency projects, such as those for increasing the efficiency of wood or charcoal burning stores, that would help reduce unsustainable use of firewood. Times promotion of biofuel activities that restore degraded land and biomass cover in order to produce, harvest, and utilize biomass in sustainable ways. Times carbon sink protection, enhancement, and restoration projects that improve carbon storage in biomass and soils, and help to prevent or control land degradation, especially desertification and deforestation. Times assessment of national, regional, and low subregional vulnerability to climate change, where appropriate, reliance on related data gathering systems to measure climate change effects in particularly vulnerable countries or regions and strengthening such systems as necessary, and identifying a near-term research and development agenda to understand sensitivity to climate change. Times evaluation of policy options for adequate monitoring systems and response strategies for climate change impacts on terrestrial and marine ecosystems. Times assessment of policy frameworks for implementing adaptation measures and response strategies in the context of coastal zone management, disaster preparedness, agriculture, fisheries, and forestry, with a view of integrating climate change impact information, as appropriate, into national strategic planning processes. Times building of national, regional, and or subregional capacity, as appropriate, to integrate climate change concerns into medium and long-term planning. Managing international waters. The global environmental benefits can be achieved if the international bodies contribute primarily as a catalyst to the implementation of a more comprehensive, ecosystem-based approach in managing international waters and their drainage basins. It is required that countries better understand the functioning of their international water systems, gain an appreciation of how their sectoral activities influence the water environment, and find means for collaborating with neighboring countries to collectively pursue effective solutions. As such, primarily countries may make changes in the ways that human activities are conducted in different sectors and make priority environmental interventions. Priorities may be on addressing the following: imminent threats to international waters, times control of land-based sources of surface and groundwater pollution that degrade the quality of international waters. Of special emphasis is the prevention of releases of persistent toxic substances and heavy metals that cannot be neutralized by marine and freshwater ecosystems or that accumulate in living organisms. High priority is also placed on abatement of common contaminants such as nutrients, biological contaminants, or sediments that endanger species or threaten ecosystems. Times prevention and control of land degradation where transboundary environmental concerns result from desertification or deforestation. Times prevention of physical or ecological degradation and hydrologic modification of critical habitats, such as wetlands, shallow waters, and reefs that sustain biodiversity, provide shelter and nursery areas for the production of fish protein sources, and otherwise are important for restoring and maintaining ecosystems associated with international waters. Times control of unsustainable use of marine living resources as well as non-living resources resulting from inadequate management measures such as overfishing, excessive withdrawal of freshwater and resource extraction, and times control of ship-based sources of chemical washings and non-indigenous species that can disrupt ecosystems or cause toxic and human health effects. There are strong and complex linkages among land use policies and practices, land degradation, and the impairment of water-related ecosystems. Land degradation is linked to sediment pollution and salt intrusion in rivers, lakes, and aquifers, vegetation loss, overpumping of groundwater, and salination of soil. Heavy sediment loads damage aquatic and marine biodiversity, make rivers more prone to flooding, and result in damage to cropland and, therefore, Lowered food production. Dryland river, lake, and groundwater basins, which are often transboundary in nature, are critical to the well-being of some 1 billion people who live in areas at risk from desertification. Improved water management in dryland transboundary basins is fundamental to enhanced food security, reduction of risks of drought or flood, and better environmental management. In dryland regions, improved management of groundwater supplies is essential to support sustainable development. Some groundwater systems may be dynamically linked to surface waters through indirect recharge processes, while others contain older fossil water that must be carefully managed if future generations are to use them. Sustainable development cannot proceed in these transboundary basins without a cooperative, multi-country water resources management strategy that integrates land and water use decisions, determines the environmental capability of the basin to sustainably support different sectoral water uses, places priority on protection of unique aquatic environments and flows needed to sustain them, explores options for reducing water use to sustainable levels, and contains provision for emergency planning to address variable flows. Recent technological developments in satellite technology and remote sensing should help to ensure access to necessary hydrologic information for preparing needed strategies. Improved watershed and catchment management, sustainable land use, soil conservation systems, reforestation, and vegetative rehabilitation, accompanied by changes in sectoral, social, and economic policies, can help address transboundary water-related environmental concerns. A comprehensive approach to integrate land and water management activities to prevent land degradation and rehabilitate degraded catchment areas may be included as part of an international waters project. The emphasis may be on facilitating regional and international cooperation on initiatives that demonstrate a comprehensive approach that integrates the management of land and surface groundwater systems and coordinated land use planning and management, relying on technology-based information systems, information networking, stakeholder involvement, extension services, regulatory frameworks, and incentive systems. 6.5 Activities. In this unit you have learnt about the challenges in conserving and managing the environment. You have also studied about measures to be taken for conservation and management of the environment for its sustainable development. After going through the unit you may have developed interest in knowing about the environmental degradation in the area where you live and may also like to inquire about the measures taken by the local authorities for reducing the risk of climate change, conserving the biological diversity, reducing degradation of land and water bodies. You may undertake one of the following studies: investigations related to environmental degradation and its sustainable development, and publish your findings. 1. Biodiversity loss. Times inventory of species and documentation of biodiversity loss in the region. Times identification and analysis of major causes of biodiversity loss in the region. Times documentation of the activities undertaken by the local authorities and the non-governmental organizations, NGOs, to build awareness of the biodiversity loss in the region. Times documentation of remedial measures undertaken by the local authorities. Documentation of the financial and technical assistance given by the central government international bodies to the local authorities to implement the remedial measures. 2. Climate change. Times gathering of data related to climate change in the region. Times assessment of regional vulnerability and sensitivity to climate change. Times identification and analysis of major causes of climate change in the region. Times documentation of the activities undertaken by the local authorities and the non-governmental organizations, NGOs, to build awareness of the climate change in the region. Times documentation of remedial measures undertaken by the local authorities. Times documentation of the financial and technical assistance given by the central government international organizations to the local authorities to implement the remedial measures. 3. Degradation of water bodies. Times gathering of data on degradation of water bodies in the region. Times assessment and estimation of common contaminants that threaten water related ecosystems of the region. Times identification and analysis of major causes of degradation of water bodies in the region. Times documentation of the activities undertaken by the local authorities and the non-governmental organizations, NGOs, to build awareness of the degradation of water bodies in the region. Times documentation of remedial measures undertaken by the local authorities. Times documentation of the financial and technical assistance given by the central government international organizations to the local authorities to implement the remedial measures. 4. Land degradation. Times gathering of data on land degradation in the region. Times identification and analysis of major causes of land degradation in the region. Times assessment and estimation of causes that threaten land-related ecosystems of the region. Times documentation of the activities undertaken by the local authorities and the non-governmental organizations, NGOs, to build awareness of the land degradation in the region. Times documentation of remedial measures undertaken by the local authorities. Times documentation of the financial and technical assistance given by the central government international organizations to the local authorities to implement the remedial measures. 6.6 Summary. Times in this unit you have studied that consumption-oriented development trends are posing serious threats to the environment. Ecosystems critical to the functioning of the Earth's life-supporting systems continue to be undermined, and land degradation threatens food security and livelihoods. Efforts are being made by environmental activists, governments and international institutions to reduce the risks of climate change, conserve and sustainably use stock of biological resources, protect international waters, phase out ozone-depleting substances, and combat land degradation, keeping in view of the fact that conservation and sustainable use of the environment are required to alleviate poverty and improve quality of life of all. The GIS technology helps us acquire information about the status of the environment and has many applications in conserving and managing it. Times various policy guidelines, action plans, and management techniques are necessary to achieve the goal of sustainable development, along with conservation and preservation of the environment. We must incorporate environmental values into all our priorities and actions. This includes repositioning our economies, not necessarily toward producing less, but definitely toward producing and consuming differently. Times incentives need to be provided for resource conservation through regulations, charges, inducements, or other means. Fragile and limited resources, poorly defined or non-existent property rights, limited access to credit and insurance markets, low income, are the reasons for majority of the world's people generally being unable to invest in long-term environmental protection and resource conservation. Times by adopting new strategies for conserving and sustainably using biodiversity, we will preserve not just the many free economic benefits We take for granted agriculture, pharmaceuticals, the raw components of our material civilization, but also the cultural, spiritual, and purely biological values inherent in our natural world. New policy and technology approaches offer opportunities for reducing greenhouse gas emissions while putting our energy future on a sustainable footing. Times local water problems of the 1970s have become the transboundary problems of the 1990s, linking the global water cycle to urbanization, watershed degradation, deforestation, biodiversity loss, and climate change. Times by initiating the phase-out of ozone-depleting chemicals during the 1970s, we are already experiencing a lower incidence of skin cancers than scientists originally predicted. Enforcement efforts continue, but it is clear that lessons and the momentum gained from this success can help to carry us forward on other fronts as well. Times prevention and control of land degradation, especially desertification and deforestation, are critical to achieving sustainable development at the national level. They are also central to global environmental progress. Times countries are adopting a variety of policies and measures to conserve biodiversity, prevent climate change, and degradation of international waters. These include improved farming and grazing practices, afforestation, reforestation, and forest management, upgraded water management, and institutional and policy reform for better land use. Policies. Times integration of environment and development concerns and greater attention to them will lead to the fulfillment of basic needs, improved living standards for all, better protected and managed ecosystems, and a safer, more prosperous future. No nation can achieve this on its own, but together we can, in a global partnership, and should strive for sustainable development. Thank you. Subscribe to our channel for more updates